Well, welcome to the Metamorphic Rocks. In today's session, we will be talking about metamorphic rocks and the rock cycle. Now, sometimes sedimentary and igneous rocks, and we talked about those in the last two sessions, but sometimes these rocks are subjected to pressure, and the pressure is so intense or the heat so high that they're completely changed. Now, stop for a second. I know some of you are thinking, wait, Mr. Ratoon, if this heat is so high, wouldn't it melt it and form igneous rocks? Well, the heat's high, but it's not quite that high. And so if it's high but not hot enough to completely melt it, they actually become metamorphic rocks, which form while deeply buried within the Earth's crust. Now, the process of metamorphism does not melt the rock, but instead it just transforms them into denser, more compacted rock types. Now, new minerals are actually created either by the rearrangement of minerals, components, or by the reaction with the fluids that enter the rocks. Now, metamorphic rocks are classified as foliated or non-foliated, and we'll go through each one of these samples. Now, some kinds of metamorphic rocks, like gneiss, so it looks like gneiss or gneiss, but it's actually pronounced nice, just like N-I-C-E, but just spelled differently. Gneiss and slate. These are strongly banded or foliated rocks. So if you think back to the sedimentary rocks where they have strata and layers, you can see the layers. What happens is foliated metamorphic rocks are those in which the minerals have been flattened and pushed down into parallel layers. And these bands in foliated metamorphic rocks actually look like the pages in a book. And I'll pass around some examples where you can see this. And I've got a good example for you right here. So this is your gneiss. So you can actually see the layers. Now this may not look quite like the layers of the book. I've got some better samples for you, but you can definitely see the different layers, the minerals that have aligned and banded together. And then we have some slate. Now you might look at slate and you can actually see it if I pull out the pen right here. So just let me grab a pen off my... So you can kind of see it like right in here, where you can start to see the different layers matching up. So I'm going to pass them around. You can kind of see it in here too, where you can see the different things coming around, and that would be the different layers that have banded together. And you might look at slate and say, wow, this looks like some other rocks. What does slate look like? Does it look a lot like the shale that we talked about in the sedimentary units? And if it does, you're right. Slate actually does come from shale. So shale was originally a sedimentary rock, but because of either heat or pressure, in this case pressure, it formed a metamorphic rock. The gneiss that you saw in the last picture actually could come from shale or it could come from granite. And even things like basalt will form other metamorphic rocks if they're subjected to the right conditions. Non-foliated rocks are metamorphic rocks that do not display any of these layers. Rather, they are massive structures with no obvious banding. And a good example of a non-foliated rock is quartzite. And we have a lot of quartzite here in the Baraboo area. It's a very smooth texture. Sometimes it almost looks glassy. It looks shiny. And it was metamorphosed from the mineral quartz from sandstone. So our bluffs here in Baraboo was once sand. It was once... some scientists theorize it was once a beach formed from an ancient sea here. And this sand became sandstone, then it became, or it metamorphosed into Baraboo quartzite, which is a very, very hard rock. So if you've ever looked at it, if you ever get the right piece, it actually looks a little shiny, which would make sense because remember, sand is the same stuff you're going to make glass out of, and obviously glass is going to be shiny. So here you see a piece of that quartzite where you can see I've got the pen on it right here, so you can see that it's pretty shiny, that it's bright. It's not necessarily going to be dull. And here's some quartzite. Now, if this looks familiar, remember in our last session on sedimentary rocks where we talked about how if you have a beach and you have the ripples, that sometimes these ripples will become part of the rock feature? Well, this once was sandstone. And this was once a beach. Now, whether it was the actual beach or whether it was a layer that settled on top of the beach. And so this is kind of like a mold of the original beach. But if you look at it, I actually have a book here. I've got the pen right here. So if you look at it right here, I've got a book. And this is a standard size book, and this is to show you size perspective. This is a huge wall, and it's not flat. It's actually vertical. If you stand up here, if I stood up here, I'd probably be about this tall. This is about 6 feet, but it just goes up and up and up. And what happened was that this was horizontal at one point in time, but some geological features, the same features that created the quartzite here in the Baraboo area, actually turned this wall on its side. Now it's going straight up and down. Here's a piece of marble, and if you look at marble, marble actually came from limestone. And when we looked at that quartzite, we already talked about how it came from sand and shale, and will not only form sometimes metamorphic rocks that are banded, but they can actually form some rocks that are not banded, such as the hornfels. Now, pressure, temperature. These are the two buzzwords. Whenever you hear temperature or pressure, that's when you got to start thinking about metamorphic rocks, as long as the temperatures aren't hot enough to melt a rock. So pressure, temperature can even change previously metamorphosed rocks into new types. So you might have one metamorphic rock and it's subjected to even more heat and pressure, and it'll actually change into a new type of metamorphic rock. For example, here you have your mica schist. It came from shale and or slate, and you're going to have mica in there as well, which is why they call it mica schist. If you looked at this, it would be like really glittery. I want to say that glittery, where it's shiny. You look at it, it almost looks like a huge piece of rock that it looked like it was melted, but it wasn't completely melted. It looks like it's all just come together. And then we got a sample of this and we'll pass it around. It's not necessarily this color, but it'll be a good example for you guys to see for the test. Now, we're going to spend a few minutes talking about the rock cycle. The rock cycle basically says that all three types of rocks in the crust are continually being created, changed, destroyed, and created anew. And this constant gradual process is called the rock cycle. So here's a picture of what the rock cycle would look like, where you have igneous rocks. And I'm going to pull out my pen for this one. And I am going to, let me change color so you're going to see that pop into the top of the screen. I'm going to go with a blue. I'm going to go with a little bit thicker pen here. Oop, I'm going to do this. Okay, so when we start igneous rocks, how do you get igneous rocks? Well, in order to get igneous rocks, you have to have magma. So it doesn't matter what type of rock you are. If you're a metamorphic rock and you melt, you form magma, you're going to become an igneous rock. Same thing here, sedimentary rocks. I know the arrow doesn't point there, but we could have another arrow coming around here saying, okay, if sedimentary rocks melt, they're going to form magma, they're going to cool, they're going to solidify and become an igneous rocks. Anytime you see the buzzwords heat and pressure, heat and pressure, heat and pressure, all these arrows point right to metamorphic rocks. And then finally, anytime these rocks, whether it's igneous rocks, metamorphic rocks, or sedimentary rocks that are weathered and broken down again, anytime these form sediments and then come back and are cemented, compact and cement together, they form sedimentary rocks. And when we look at these rocks, they form a cycle. And this cycle is a good cycle because if we didn't have this cycle, all the rocks that were created once they're destroyed, they're done. But because we do have the rock cycle, all these rocks are created anew and they're created over and over and over. So if you think about it, with weathering and erosion, I know we're going to get into that unit later in the year, but with weathering and erosion, the breaking down of rocks, the earth would be completely flat if it wasn't for the rock cycle and the recreating of rocks. So the rock cycle is actually very, very good for us here on our planet. Now in the rock cycle, igneous rocks are formed from the cooling and hardening of molten material. Sedimentary rocks are produced from sediments that are compressed and cemented in layers. And metamorphic rocks are produced when sedimentary and igneous rocks are subjected to great heat and pressure deep inside the earth. Now that does conclude our notes. So hopefully, if you have any questions, you'll be brave enough to come and talk to me. I'm not a scary person. So when you do come in, just make sure you know what questions you want to ask, and I will help you. You are going to have to know the metamorphic rocks, the igneous rocks, the sedimentary rocks. You're going to have to know the rock cycle for the test. So know how those rocks are created, know some examples of each rocks. On the rock test, I'm actually going to have 13 different types of rocks from all three categories that you're going to have to identify. So again, if you have any questions, just come on in and see me. Thanks.